Hello everyone. In this video, we'll see how to convert any given Boolean function into standard or canonical form. Okay. Under this, we have two things. One is standard SOP form, that is sum of products. Other one is the standard POS or product of sums form. Okay. So we have to now see how to convert a given Boolean function into its standard form. Right. So let me take a small example here. Let's say three variable. I have function of three variables, and let's say the equation is a bar b plus a c bar plus b. Okay, so they have given an expression, but if you look at the expression, you can say that this has been simplified in some form because each product term or each min term is incomplete. It has missing variable in it, right? So this is not standard form. This is simplified form of the Boolean function. Now I have to convert it into standard form. What's the meaning of standard form? Every minterm that is there in the equation should have all the variables of that function. For example, if I take the first one, it has only a and b. C is missing. So you have to include the c in the equation in such a way that this particular term will have all the three variables a, b, and c. If I take the second one, b is missing, I have to include it. And in the third term, both a and c are missing, I have to include it. Okay. So after including the missing terms, I have to write this equation. I have to make sure that all the product terms in this equation will be having all the three variables in them. Okay, that is standard form where you have to make sure there are no missing terms in any one of missing variables in any one of the product term. That is in SOP. Okay, so we'll see now how to include this missing term. So let's take the first one, a bar b, right? So what is missing here is c. So a bar b can be written as a bar b into 1, correct? And operation between a bar b and 1 gives you a bar b as it is, right? So I can just multiply it with 1, binary multiplication. Now, in place of 1, sorry, can I write c plus c bar, a variable binary added with its complement is always going to be 1. This is your conditions or rules of the Boolean algebra, correct? C plus c bar is nothing but 1. Now we can apply distributive law, open bracket and multiply. You're going to get a bar bc plus a bar b c bar. So you have included the missing term c such that now you have the product terms which has all three variables in them. Okay, so this is how you include missing term for SOP format, right? Now we'll try for the next term, AC bar. What is missing here is B, and B is supposed to be second element, okay? Please don't interchange the order here. Make sure it is A, B, C only. The order of the variable should be A, B, C, right? So I have to put 1 in between these two terms. So now it becomes B plus B bar into C bar. Open bracket and multiply, I'll get A, B, C bar plus A, B bar, C bar, right? Now the last one, A is missing. There are two terms which are missing in this, but we'll do one by one. First, we'll try to include A. So 1 into B, that is A plus A bar into B. I'll get AB plus A bar B. Now in both of them, C is missing, so I can include it like this, plus A bar B into C plus C bar. So I'll get ABC plus ABC bar plus A bar BC plus A bar B C bar. So all the three product terms, whatever was missing in that, you have included it. Now your final answer will be sum of all of them. So it will be from the first one you got two terms, A bar BC plus AB C bar. The second one you got ABC bar plus AB bar C bar. In the third you have four values, ABC plus ABC bar plus A bar BC plus A bar B C bar. The next step what you have to see is if there are any repeated terms, you can eliminate the repetitions and keep it only once. Okay. So first I'll write this A bar B C. And the next term is A bar B C bar. It is not repeated. I'm just writing it. Next is A B C bar. Next A B bar C bar plus A B C. Less, when you come to this A B C bar, you see it is already written once. So you can eliminate this. You don't have to repeat again. Next term is A bar B C. That is also that's already done again. This is also not required. Then you have A bar B C bar, which is already written, not required. Okay. So which means repetitions have been eliminated. You're supposed to write the value only once, right? So this will be your final answer now. So in the question, if they ask you to write the standard SOP form of a given function, this is where you have to stop. This should be your answer. Include all the missing terms and stop here. Now further in the question, if they ask you to write the canonical minterm form of this equation, you need to do two more steps here. Whatever equation you've got in this uh, final stage, convert it into binary format. Okay. So binary of complement will be 0. For the variable, original variable or uncomplemented variable, it is 1. Like that, you write the binary value of all the product terms. Okay. This will be 0, 1, 0, 1, 1, 0, 1, 0, 0, 1, 1, 1. So once you have written the binary, next step is convert this binary to decimal. So 0, 1, 1 in decimal is t. This will be 2. This is 1, 1, 0. That is 6, 4, 7. And now write these numbers in order with the symbol summation small m 2, 3, 4, 6, 7. This is called canonical minterm form or canonical SOP. This is standard SOP. Standard SOP. Okay. So this is how you have to convert the given expression into standard SOP or the canonical minterm SOP form by including the missing terms. I hope this is clear. I'll give you one simple way to write this, one simple method, or which I found easy to use. Let's take 4 variable, okay? Or okay, otherwise we'll do the same question. We'll try to solve the same question with this method. I'll take the same inputs. I have A bar B plus AC bar plus B. Okay. So now I'm directly going to, I'm not individually adding C plus C bar and then multiplying it, all that. I'll directly tell you how we can do this. Now just check. In the first term, you have only one variable that is missing. Okay, one variable. If I say A, a single variable, what are the possible binary values this A can take? The A can either be 0 or it can be 1, which means you have two possible values for one variable. So similarly here, in this term, there is only one variable that is missing, which means it can be either a 0 or it can be a 1. If it is 0, it will be C bar. If it is 1, it is going to be C. Correct? So I'll just write like this term as it is, A bar B and A bar B. Since one variable is there, I will be having two possibilities now. The first possibility is that C is 1, so I'll write C as it is. Second possibility is that the C might be 0, in which case I have to write it as C bar. So from the first one, I got 2. I hope this is clear, right? If there is only one variable missing, two possible outcomes will be there for 1 or 0. Similarly, I will do for the second one. Here also only one variable is missing, which means there are two possible outputs I can get from this gap. And because B comes in between, okay, and the possibility is either it can be a B or it can be B bar. Okay. A given term as it is, you have to mention it. Missing term is included based upon its possibility, whether it is 0, 1. If it is one variable, it is only 0 or 1, two possibilities. Next one is continue. The third term has two missing variables. If you have two variables, you have four possible combinations, right? Correct? So 4 possible combinations are there, which means your output will be having 4 terms. I'll write B 4 times and then include the missing terms there based upon the combination. So first combination is 0 0, which means it can be, since A and C are missing, 0 0 means A bar, C bar. The next combination is 0 1, A bar, C. The third will be A, C bar. The fourth is A, C. Okay, you keep the given value as it is, and whichever term is missing, you can write its possible outcome along with the given term. If there is only one variable, you'll have two outcomes. If two variables are missing, you'll have four possible outcomes. If three variables are missing, you'll have 8 possible outcomes there. Okay, this is easy way of writing it, but please look at the marks and the question. If they're asking it for maybe 6 marks or something, don't write the answer in single step. You please show the at least for one variable, you show how it is done. Mention the procedure, actual procedure, how it is done. Okay. Later, if it is only for maybe 3 or 4 marks, you can just write the output. I hope the step is clear. If you want, I can take a 4 variable example and repeat it once. Let's take a 4 variable A, B, C bar plus B bar D plus and take C bar. Okay. So now if I look at the first term, there is only one variable missing, that is D, which means one variable means 2 possible outcomes are there. So I'll write this A, B, C bar 2 times and include the missing term. If there is only one variable, 2 outcomes are there. Either it can be a D or it can be a D bar. Okay. For the next case, that is this. You have B and D, but A and C, 2 variables are missing, A and C. If 2 variables are missing, then it means 4 combinations are there. So I'll write this B bar D 4 times, leaving some gap for, you have to leave the gap for the missing one. A, B, C, and then D. Okay. So again, A, B bar C, D. Leave space for the 2 variables in the right position. Repeat this 4 times because 4 possible combinations are there. First combination is 0 0, that is A bar, C bar. Second is A bar, C. A, C bar. A, C. Order is very important. Don't put A and C in the end or in the beginning or somewhere in between. It should be in the proper order as mentioned in the question. Okay. Now coming to the last one. I'll write it here. Okay. There's no space. Here you have 3 variables missing, that is A, B, and D. If 3 variables are there, 8 possible combinations will be there. So write C bar 8 times. C bar, C bar, C bar. You'll have to write it 8 times. Okay. Now the combinations can be 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. This is for A, B, and D, missing terms. So it can be A bar, B bar, D bar, A bar, B bar, D, A bar, B, D bar, A bar, um, A bar, B, D, 0 1 1. Okay. Next is A, B bar, D bar, A, B bar, D, A, B, D bar, A, B, D. This is your complete form. Now, next step, if there are any repetitions, you can eliminate the repetitions. Keep only the term once, okay? You have to not repeat it. You have to write product term only once. Repetitions can be eliminated, right? I hope this is clear now. This is how you can convert any given equation into its standard form. And if at all they ask you to find the minterm form, minterm representation, once you get the final answer, convert it to binary, binary to decimal, and then write the numbers in the order along with summation m. That gives you minterm form. Okay. Now coming to the SOP conversion, standard SOP. Let's take an example. I have this f of ABC function, and here the equation will be given in terms of product of sums. Okay. A plus B into B bar plus C into maybe B, something like this. This is sum term multiplied. Okay. Sum terms are multiplied. Product of sum terms. Okay. So here, how do we add the missing term? Let's consider the first one, that is A plus B. So I can write like this: A plus B multiplied with 1, right? Sorry. Okay. So when you have SOP form, you can also write this A plus B plus 0. If you add 0, it doesn't make any difference, correct? So A plus B plus 0 is nothing but A plus B, right? So A plus B plus, can I write 0 as C into C bar? Because a number with its complement, if I take the product or binary multiplication, it's going to be 0. So now we have to put distributive law. A plus B plus C plus, sorry, multiplied with A plus B plus C multiplied with A plus B plus C bar. Like this. Okay. So from one, if there is one missing variable, you get two terms. Similarly, the second one is B bar plus C bar. A is missing. So A into A bar is added with B bar plus C bar. So I'll get A plus B bar plus C bar and A bar plus B bar plus C bar. For the last one, you have two missing terms. So A bar plus B, I'll get A plus B, A bar plus B. Now these two have missing term, that is A plus B plus C bar, A bar plus B plus C bar. So you'll have total four terms if there are two missing variables. See, A plus B plus C bar, A bar plus B plus C, A bar plus B plus C bar. Now your final equation will be all these terms put together, sum it, okay? I mean, take the product of all the terms. Everything should be taken together. These are the first two, then the second one, and the last one. Okay. Again, the condition remains same. Do not repeat the terms. If there are repetitions, eliminate them. Keep it only once. A plus B plus C is already written. Don't write it. A plus B plus C bar is also done. A bar plus B plus C is not there. Included. A bar plus B plus C bar is also not there. Included. Okay. This will be your standard POS equation. Now, if they ask you to write the canonical max term equation, then convert this to binary, from binary to decimal, and then write the numbers. Okay. But how do you convert this into binary? The rule is now different because you are doing for POS equation. So whenever you're writing binary for a POS product term, whenever you're writing the equation for a product of some problem, it is going to be exactly opposite of what you have done in SOP. In SOP, what you do, if there is a variable A, you write it as 1. If it is A bar, you write it 0. Here it is exactly opposite. If it is A, it is 0. If it is complemented, it will be 1. Okay. Just remember SOP. Opposite of that will be for POS. Okay. Uncomplimented is 0. Complemented is 1. So for that, if I follow that rule, I'll be getting something like this. Complement is 1. Uncomplement is 0. Now write the decimal of the 0, 1, 3, 7, 4, 5. Final answer will be the arrangement, orderly arrangement of these numbers. 3, 4, 5, and 7. but the symbol will be pi m. This is product of max terms. Okay, this is max term, capital M. So this is the canonical max term form. Okay, there's a shortcut also, just like how you did previously. You can use a shortcut for this too. Directly, you can write the equations. I'll show that. I have a plus b. Let's take four variables, make it easy for you. Next is a bar plus c and b bar. Okay, so I can directly write the terms here. As I told you, if there is one variable, two possible outcomes will be there. So I'm going to repeat this two times, leaving space for the missing variable. So one variable d is missing. It has two possible outcomes. It can be either d or d bar. In the next one, you have two variables missing, b and d, which means four possible outcomes are there. So I'll take this a bar plus, I will leave space for b, c plus leave space for d. Like this, you have to repeat four times. Now take the combinations 0, 0, b bar, d bar, b bar, d, b, d bar, b. Okay. Coming to the last one, you have three variables missing. That is a, c, and d. So eight combinations will be there. Leave space for a, write b bar, leave space for c and d. Repeat this eight times. Three, four, five, six. Now combinations a bar, c bar, d bar, a bar, c bar, d, a bar, c, d bar, a bar, c, d, a, c bar, d bar, a, c bar, d, a, c, d bar, a, c, d. Okay. Further, if there are any repetitions, eliminate and write it only once. And you should be having all unique terms in the end. And then if they ask you to write the max term, take the binary decimal and from there list it out with pi m. Okay, pi capital M. And when you're writing the binary, make sure that uncomplemented variable will be 0, complemented variable will be 1. This is for POS. Whereas for SOP, uncomplimented is 1, complement is 0. Okay, here you have summation m, that is sum of minterms. Here you have pi m, product of max terms. Okay, so this, and one more thing here, how do you include the missing term? You multiply with variable and its complement. Here, how do you include it? You add with variable into its complement. Okay, here it is product, within the bracket addition. Here it is sum, and within the term it is product. Okay, this is POS, and I think I did a mistake. I'm sorry. I'm sorry. Mm, it should come this side. I've written POS first. I'm so sorry. I'll repeat this. This is SOP and this is POS. Okay. In SOP, it is sum of products. So you will be having min terms. Here it is max terms. So for any variable, it is 1 and its complement will be 0. Exact opposite happens in POS. Okay. If they ask you to write it in the equation number form, it is summation small m. For POS, it is pi capital M. And the rule for adding the missing term is here it is uh, dot multiply with variable and its complement. Here it is add variable into its complement. Okay, so this is how we include the missing term. This is the comparison between SOP and POS. Please remember this. You'll be able to convert any given Boolean function into its standard form. Okay, so that's it for this video. Thank you.